Okay, there you go. Anyway, I hope you had a nice weekend. And sports are still clicking. We're still coming to school. I'm grateful for that. Just keep doing what you're doing. Try not to, don't loosen up that much more. Keep doing what you're doing. And we'll keep meeting in school. Certain colleges are going back. That's good. All right. We have, this Thursday, we have a test on Chapter 2. And I mentioned it last week. And there are 3 parts to it. And what are the 3 parts? The scientists. So that'd be a matching. So what you would do is, on the front page, if you simply had a little thing about each scientist and just, I know there's a lot of names there, but that'd be a matching. So you should be able to match a few of those. So make sure you don't underestimate that. But it is kind of matching. And then the second part would be about ions and isotopes. That would be mainly about the grid game. Everybody know that? Does everybody know the difference between mass number and atomic mass? Which one's always a whole number? Mass number. That's the number of nucleons, right? The atomic mass is an average mass of the isotopes with their abundance, right? That's why it's a decimal number. But the bulk, I'd say the bulk of the test is nomenclature, right? Nomenclature, yes.
I don't know if you said this last week, but you said you didn't know. Do you have a plan for when that test is?
Thursday, yeah. So anyway, today we're going to finish all the nomenclature. We'll review types 1, 2, and 3, and then it really does not take that long to teach types 4 and 5. I'm not worried about types 4 and 5. Okay, if you have types 1, 2, and 3 down really solid, acids are type 4. And then binary molecular compounds are like carbon dioxide, that's 5. I'm not worried about those so much. And then it's just practice. We'll essentially be done. We'll probably be done today. And that's practice. So tomorrow, we'll practice. And then the next day, we'll practice. You get that? We can get some of the games. I remember the games, the polyatomic ions. I can get some of those out. We can do that. So that's my plan. So what I'm going to do, I thought today, how I start out, is imagine after a 3-day weekend and you didn't study, what if someone asked you to take a piece of paper out and write as many polyatomic ions as you could? Now, my own opinion is, if that was a quiz grade, a pop quiz, I could do that, but I don't think that's fair after a 3-day weekend. But let's just say this. What if we just went around the room? Let's just go around the room and let's see how far we can keep it going, all right? So you're going to give me one. You give me one. If you just absolutely can't, you can say pass, okay? All right, you ready? Now, this was without looking. You ready? All right, tell me the charge and then tell me the name and how to write it.
Righty, so ammonium and the charge is +1.
Okay, what is it?
Ammonium.
Yeah.
And then
And what?
H, I think. Or no, it's not H.
Yeah, this got to go a little faster than this. It's got to go a little bit. Let's go a little bit faster. Give me one you absolutely know. So you say NH4 +1, right? And you have to have that thing there. If you don't have it, it looks like a compound. It's not a compound. Okay, ready? Go.
Nitrate and
Where?
-1
Okay, give it to me.
NO3.
Yes.
Nitrite.
That's a good.
NO2.
No, I would do that.
Phosphate -3. PO4.
Okay.
Acetate.
Acetate. All right.
-1. C2H3O2.
2, 3, 2. Okay. Is that one?
Dihydrogen phosphate.
Wow.
-1.
All right. What is it?
H2PO4.
Really? That's the one you memorized? Okay.
Yeah.
That's interesting.
Phosphite is -3.
Oh, well, he's catching on.
PO3.
You catching on to the game here.
Carbonate, CO3, -2.
All right, keep it on a roll. Keep going. Calvin.
Sulfate -2, SO4.
Very good.
So I tested for
Oh, you guys are smart. I knew you were.
Cyanide -1.
Oh. What is cyanide? All right. Carson, you weren't here, but
Silicate.
whoa. All right, what's the charge?
It's 2.
-2? What is it?
SiO3.
And what's the name?
Silicate.
Silicate.
Mercury 1 +2.
What's the charge?
It's +2.
How do you write it?
H2. Or wait, Hg2.
Say it again.
Hg2.
Okay. So diatomic mercury, Hg2 plus 2. J- Very good. We're on a roll. Jonah. Okay, go ahead. You were breaking the back row, so you gotta help me.
-1,
Okay.
and M and O4.
Very good. All right. All the way back up.
We might break the rule.
Get a little harder.
There's one called perchlorate.
There is. Once you can start with chlorate.
Is that -1?
Yeah, they all of them are.
Okay. We see.
Do you want to do chlorate or perchlorate?
Because,
I think you start with chlorate. It's a good framework to do the other ones, but
okay, so ClO. And
CLO what?
then all four of the ones sound like have like, yeah.
Okay, chlorate. There we go. Oh, I should have maximized this. All right. I didn't know that. All right, keep going. You want to build off of this one, or
hyperchlorate?
what is it?
Hyperchlorate, and that's H.
How about do chlorite first? This is chlorate.
Oh, then ClO2.
Yep. You only look. It was one. All right. You want to finish or not finish?
hypochlorite.
Hypo. It's even lower than chlorite. Lower number of oxygens than chlorite. And then why don't you go above and give me the one perchlor. Yes. It's even higher than chlorate. All right. There we go. Ooh. Everybody get that? All right.
Chromate -2. CrO4.
Oh. Okay.
Hydrogen phosphate
Where you want to put it?
-2.
Okay. I like this. I like hydrogen phosphate.
We don't have, do we have sulfate or sulfite?
We don't. We have sulfate and sulfite. This without studying. It's without studying, right?
Can I pass?
Pass.
Dichromate, CR2.
Charge.
-2, I think. CR207.
Yeah. To me, it's almost like doubling chromate. Doubling chromate would be CR208. So it's really close to doubling. It's close enough for me to remember it. CR207. Dichromate.
Pass.
Hydrogen sulfate -1 HSO4.
So if I had sulfate, hydrogen sulfate.
Peroxide. -2.
Here. How do you write it? Ah, that's a good one. That's a game winner. If you're playing this game with somebody. This is another exception to the rule, just like this one was. There's only one time where oxygen is not -2 in a compound. It's in a peroxide. So when you want to write peroxide, just write O2 -2. Okay? All right, you did a good job. Next, Carson. Pass. Pass.
Oxalate.
Okay, what's that one?
-O2.
Say it again.
It's C2O4.
Oxalate. Okay, we don't use that too often. Joan, you got one?
Bromate?
What is it?
Bromate?
Now I have chromate and dichromate. So what do you want?
Bromate.
Oh, bromate. Go ahead.
It's made of one part.
Okay.
BRO3.
Okay, that's a new one. There you go. Do you have any more?
No.
All right. Anybody else just absolutely memorize it? And I didn't look it up. Anybody have another one to add? Yes.
Hydrogen sulfide, HSO3.
Okay, this was hydrogen sulfate. So hydrogen sulfite. Very good. Now let's take a look and let's see which ones that we were not able to come up with. Take a look at the +3. We had phosphate and phosphite. You did a good job on that. The +1, ammonium, and the +2, it's called mercury 1. It's called mercury 1, right? Okay, got that one down. And now let's take a look at the -2. You picked up the peroxide, which is a hard one. That's a hard one. That's an exception to the rule. And then you had hydrogen phosphate and hydrogen phosphite. Oxalate you got, sulfite, sulfate, carbonate, chromate, dichromate, silicate, and this is a new one for this year, thiosulfate. So thiosulfate, for whatever reason, the thio has to do with sulfur. I don't know exactly why, but notice that thiosulfate has sulfur in it, and so does thiocyanate. It has sulfur in it, doesn't it? So anyway, so this is one that thiosulfate, look at. Let's look at the -1s now. A dihydrogen phosphate, you could have had dihydrogen phosphite. Acetate, you did a good job. Hydrogen sulfate, hydrogen sulfite. Hydrogen carbonate, did we have that one? And what's another name for hydrogen carbonate?
Bicarbonate.
Bicarbonate. If you look on a baking soda box, it'll say contains sodium bicarbonate. Okay, bicarbonate, also hydrogen carbonate. Cyanide and hydroxide, you did a good job on that. As a matter of fact, I think these two, what's interesting to me, yes, if they could have gone back, they should have slapped somebody and said, why would you name a polyatomic ion in an IDE when that's supposed to mean it's a binary compound, right? So hydroxide, cyanide, that was dumb. Now what I think is interesting is, guess what happened later when they wanted to name this guy? Yeah, but guess what? They said, yeah, you're right. We made a mistake. We should have called that cyanate, but we didn't, did we? But then they found this one. They said, all right, let's not make another mistake. Thiocyanate. Okay, what else did we miss? I think that's about it. I'll tell you right now, if you can do most 80% of those, you're in really good shape. If you can only do 10% of those, you're going to have to work on those. You're just going to have to work on the poly. I can't help you on those. I can show you how we did the other week. I did the famous 8s: phosphate, carbonate, sulfate, chromate, nitrate, acetate, chlorate. I would do those first, and if you knew that the famous 8s, then you would know the ites, wouldn't you? The phosphite, sulfite, and there is no chromite, nitrite, no acetate, chlorite. So now you know those. And then you know that if I just tack on some hydrogens onto this, hydrogen phosphate or hydrogen phosphite, dihydrogen phosphate, we know some more that way. We also know the chlorate series. Everybody should know this series, okay? Here's chlorate. Take away an oxygen, chloride. Take away another one, hypochlorite. Add an oxygen. I think they should have called it hyperchlorate. They just called it perchlorate, didn't they? Didn't make sense to me, but that's what they did. The other ones are kind of like a memorization thing. So you will have to memorize, a certain number of these. This one, if you double chromate, almost double it, you get dichromate. This is an exception to the rule. That's a peroxide, and that's an exception to the rule, and that's called mercury 1. Why is peroxide an exception to the rule? Like, what if I said this? Here, what if I said sodium oxide? Here, can you write the formula for that? And then write the formula for sodium peroxide. All right, try that. Write the formula for sodium oxide, and then write the formula for sodium peroxide. Let's see what happens. Sodium oxide. Na. Oxygen. Everybody with me so far? I need 2 of these, don't I? What about this guy? Did you say peroxide? Then I'm writing O2 minus 2. If you say peroxide, it's like a polyatomic ion. I'm writing O2 minus 2. Now what's the other guy? Oh, wait. How's that? Now, you see where that's an exception, isn't it? Because your binary compounds, your ionic compounds, they're always reduced to the lowest number, except this one and the ones we use mercury 1. Get that? All right, what do you think? Okay, so let's do a quick review. Is everybody okay? Type 1, type 2, type 3. Let's move to type 4, and then let's practice a lot. After we do type 4 and type 5, we're just going to practice a little bit. We might have time to play some polyatomic ion card games. How about that? Remember that game? Okay. All right. In the world of inorganic compounds, they have a special way. If you know type 1, 2, and 3, you also know how they kind of have the same rules, don't they? I use Roman numerals. I don't use Roman numerals for type 1, do I? But I would for type 2. And what about type 3? It all depends. If it's an always metal, I don't use Roman numerals. If it's not, I use Roman numerals, just like you did for type 2. So there's something together. If you know type 1, 2, and 3, you know a lot. So it doesn't take very long to teach this one, okay? But there's a group of inorganic compounds that are very special. And these compounds, when you put them in water, they do something special. They give away hydrogen ions, and they, which are protons, aren't they? And they're called acids. Now, they decided that acids were special enough that they would name them a certain way. So what you're looking for is who's the star of the show. The star of the show is the hydrogen that's going to be given off as an ion. So all your acids are written with H first, aren't they? I only know 2 compounds that are not acids that are written, H is written first. Water and hydrogen peroxide. These are not acids, but everything else that starts with hydrogen, it's an acid. So when you're when you're trying to be tested on this, if you see something that starts with H and it's not these 2, you're going to name it like an acid. Everybody get it? Okay, so here are the rules. Let's say you have all acids right here. I'll make a little flow chart. Okay, what if you have all acids, and what if you have no oxygen? What if you do not have oxygen and you're an acid? Okay, and here's the best example right here. So HCl, everybody got that? That's probably the world's most famous acid. It's found in your stomach. What's it called? Okay, so if you have no acid, if you have no oxygen, you say hydro. Okay? That gives me a clue that you have no oxygen. And then I write a branch of this, chlor, and I end with ic. So let's try it again. So if I know that you give me an acid and it does not have oxygen, I'm going to use this as my model. So let me give you 3 that are like this and tell me the names. How about HF? You must be an acid and you don't have oxygen. What's the name? Hydrofluoric acid. Right, I can do that. How about HBr? Okay. You ready for a hard one? All right. H2S. Ooh, what's that 2? Does that mean anything? No. Is it an acid? And no oxygen? What are you going to say? Hydrosulfuric acid. One more hard one. What do you got? Is it an acid? No oxygen? What are you going to say? Hydrocyanic acid. I wish somebody would have taught this to me. I really did not know there's any kind of a pattern to naming acids, but this is one kind of acid that has no oxygen. So any of those are like that. See that? Hydroiodic, hydrosulfuric, hydrofluoric, hydrocyanic. Get that? Then we have the ones that do have oxygen, and they're called oxyacids. What are they called? Oxyacids. Oh, I get it. You're an acid, you have oxygen. Okay. So now, if you're an oxyacid, it all depends on what the name of the polyatomic ion is. So, here's my example for this one. I have HNO3 and I have HNO2. Okay, now ready. What is the name of the polyatomic ion that has oxygen in it? What's its name? What's this right here? What is it? Nitrate. Now, if it ends in 8, if the polyatomic ends in 8, he's just a plain old nitric acid. Ick. If your polyatomic ends in 8, you're the ick acid. You get that? Now watch this. This guy ends in ite. Isn't this nitrite? So what is this going to be? Nitrous. Wait a minute. That's kind of like before. You're the big icky nitrate. See? Remember the ick and us? Oh.
It's not based on charge, it's based on.
I know, but is it good for a memory trick though? Is it good for a memory trick? So let me give you some acids that do have oxygen, and let's see how you do with those. All right, ready? H2SO4. Is that an acid?
Yes.
All right. Does it have oxygen?
Yes.
Okay. What's the polyatomic? Sulfate. So you must be what? Sulfuric. This is the second most famous acid in the world. As a matter of fact, this one's so famous. I don't know if you know about economies, but they have these things that are indicators of economy. And the United States have been using, if we sell a lot of sulfuric acid around the country, there's so many industries that use sulfuric acid. If we're selling a lot of it, the economy's doing well. It's a leading indicator of economic growth. See that? Anyway, so sulfuric acid. So what I'd like to do is, let me give you another one. How about that one? Is that an acid? Is that an acid? Yeah. What's the name of the polyatomic ion? Acetate? Acetic? Acetic acid is what you find in vinegar, right? Acetic acid. Now, later, when you do organic chemistry, I'll show you that they write it differently. But you know what? Not for today. Today, this is the way inorganic chemist writes acetic acid. Okay, yes?
What would we do something like cyanide?
Cyanide. Now, cyanide, remember, has no oxygen in it. So if you make an acid of it, it's hydrocyanic. Now, here's what I'd like you to do. This is a good challenge. I'd like you to write the whole chlorate polyatomic ion series out and then turn them into acids and then name them. I'm telling you, if you could do that, you kind of know what you're talking about. So write out the whole chlorate series. Here, I'll do it on a piece of paper here. Write out the whole chlorate series. Chlorate, chlorite, hypochlorite, and then perchlorate. There we go. Now, turn them all into acids. How many hydrogens am I going to need to make this into a compound? By the way, acids and bases are compounds, aren't they? But yeah, how many hydrogens do I need? 1, 1, 1, 1. There you go. Now, see if you can name all 4 of those acids. You can do it. You can do it. Again, we're going to spend a lot of time practicing. You get that? Practicing. Like all day tomorrow, we're going to practice and play some games and until we get really, really good at this. All right. Anybody want to volunteer for any one of these? Calvin, pick one.
The first one.
Okay.
Is it perchloric acid?
Well, since it ended in 8, you'd have to end in ic. So what did you say?
Perchloric acid?
You are absolutely right. So it was perchlorate, so it's perchloric acid. Very good. Yes.
Is it just chloric acid for the next one?
Next one, what is it?
Chloric acid.
You're right. It was chlorate, so it becomes chloric acid. Another volunteer. Oh, pick, yeah.
Chlorus.
Say it again.
Chlorus acid.
One more time.
Chlorus.
Ic?
Us.
Okay. Chlorus. Chlorus acid. All right, I'll get back. Yes.
Hypochlorous acid.
High what?
Hypochlorous.
Yes. Wow. What do you think? There's no way I could have done this, and I was never taught this in high school. Never. I mean, I wasn't even taught there was a pattern. And do you see the pattern at all? If you don't have oxygen in an acid, right? First of all, you start with hydrogen, your acid, right? And you don't have oxygen, it's going to be hypo. That's the only time I ever use hypo. Hypo. Not hydro, hypo. Everybody get that? Every year I have people do this. I wish you didn't, but what's the name of this right there? What's the name of that polyatomic ion? Don't do it. Don't do it. Hydrogen. Hydrogen phosphate. You get that? When's the only time you use hydro? Acid with no oxygen. See that? That's hydrogen phosphate. What do you think? Now, we'll have time to practice tomorrow. We have a whole sheet in here, and all you do is name acids. And also, just naming them is one thing, but what if I give you the name? Can you write the formula? Okay, so let's try one. I'm going to give you a hard one. Can I give you a hard one? There you go. Permanganic acid. Let's see if you get this one. Permanganic. You said ick? Mm. When you get it done, show your neighbor and see if you match. See if you can get it. Permanganic. Oh, by the way, did I tell you have to know your polyatomic ions? Oh. That's going to be the key, isn't it? All right, what do you think? Now, I didn't say hydro, so it must have oxygen in it, right? And in an ick, so the polyatomic must be permanganate. What's permanganate? But permanganate's a -1 charge. How many hydrogens are you going to need to counterbalance that? Raise your hand if you honestly had HMNO4. Okay, if you had something different, what happened? I forgot permanganate. All right. What do you think? Okay, let's do the last one. Let's do type 5. Now, I disagree. The author is way, way smarter than me. He wrote an entire book that they use in college and AP class. I'm not trying to tell you anything like that. You know, if I wrote a book, somebody could take one part and say, oh, I don't think you should have done that. I'm going to disagree with the author the way he does in your book. I would honestly leave this to the end. There's no way you should be teaching this till the end. You get it? And when do you use type 5? I'll even tell you why. What does it mean? Binary, 2 elements. What's this word? Molecular. What is it? Yes, non-metal, isn't it? See, before it was metal, non-metal. I became an ion. You're an ion. Even polyatomic ions are ions, aren't they? Those are ionic compounds. This is not an ionic compound. You put the other ones in water, and they almost all of them break up into ions, don't they? You put this in water, they just stay together. See that? So molecular means non-metal bonded to non-metal. Not ionic bond, but covalently bonded, aren't they? They're sharing electrons. Nobody's really a real ion. Now, because they're binary, you still end in IDE. I like that. This is the only kind of compounds where you look at the subscripts. Remember I told you, don't look at the subscripts to name them? Well, now you do. It's the only ones you do. And all you have to do is learn these right here. It's not that hard. There's about 2 rules. Ready? Mono at Disney World and monorail rails on 1 track. Mono means 1. Di and bi both have 2 words, 2 letters, but di means 2. Di is 2. My tricycle had 3 wheels. Tri means 3. Tetra, the Tetris game, every block comes down, has 4 blocks in it. That's why Tetris is called Tetris, because it has 4. Okay? And Penta, like the Pentagon, has 5, like a Pentagon in Washington, D.C. And Hex sounds like 6. Hex, 6. And Hepta, I don't know what that is. That's 7. And then octopus, and octagons have 8 sides. And Nona is like 9. And Deca has 10 years. Well, anyway, there's my memory trick there. Now, so what we do is we take something like this, and we go, how do you name that? Ding, ding, ding. Wait a minute. That's a non-metal and a non-metal. And it's binary, right? So we say the name of the first element, and then say the name of the second one. Okay, now, but they have a little rule, because chemists are minimalist, just like they don't say H2O1, but it is. Water is really H2O1, isn't it? They don't do that. They don't use subscripts of 1. They don't want to use mono for the first element. If it's 1, I'll just say carbon. There's only 1 carbon, right? But I do have to tell you how many oxygens there are. So you want to say monoxide. Some chemists said, I don't want to say that. Monoxide. So what did they say? Monoxide. Okay? How about this guy? Or this guy? Carbon. How many oxygens? No, carbon dioxide. Now, you know why you don't want to teach this until last? Because you'll be doing something like this. Sodium mononitrogen trioxide. Oh, what a disaster. So that's where I disagree with the author. I think he teaches that as type 3. I really would not do that. I'd teach it last. You only use it for non-metals, and it's binary. You get it? This is carbon dioxide. Let's get a little tricky here. How about that? How about that one? You don't use mono for the first element. Dinitrogen. What is it? That's it. Trioxide. All right, do another one. Phosphorus. Penta. Chloride. All binaries end in IDE. Is that right? Wow. I think I can do these. You probably wish all of them were named this way, or they don't. Like that. Now, I think what I'll do. Oh, another thing. Excuse me. What about this guy right here? What about that one? Say it. Diphosphorus. Tetraoxide or tetroxide? Did I get that? Do you notice that this is not reduced? This is not an ionic compound. There are only two exceptions in the ionic world. Remember the mercury 1 ion and peroxide? Other than that, they're going to be reduced, aren't they? You don't have to reduce these. You can have any combination you want. Non-metal, non-metal. N2O2. Get it? All right, so now, here's what we're going to do. Let's practice a little bit, all right? We're going to practice polyatomics here in a minute. All right, what we're going to do is randomly pick one. And everybody's going to do it, and we're going to see how we do. And ready? I pick number 10. Ready? 10. Without looking, can you do this? Or you say, no, I don't know any polyatomic ions in. Notice we do not look at subscripts except for the non-metal, non-metal. Remember those, the covalent ones? All right, ready? Manganese. What? Did I say manganese?
Yeah.
Oh, magnesium. That's bad. Okay, magnesium sulfate. That's what's in Epsom salt. Epsom salt. All right, let's do another one. Not so random, but I pick number 43. 43. I wish it was just copper phosphate, but it's not always metal, is it? So I got to figure this out. Phosphate was -3, and I had 2 of them. That's -6. So each one of these is -3. Is that right? That's -6. This got to be +6. 3 times +2 isn't that right? It have to come out to be 0. So what's the Roman numeral? It's always the charge on the what? The metal. Okay, everybody got that? So if you put copper 2 phosphate, you're half done. Now give me the other name using the us system. You need to memorize copper. Copper comes in +1 and +2. Iron comes in 2 and 3. What's the other name of copper 2 phosphate? All right, Joni, you got it? Cuprous. Cuprous what? That's it. Cuprous phosphate. Because it only comes in 1 and 2, and 2's the big icky. Did you say cuprous? What did he say? Cupric. I'm sorry. Cupric phosphate. Sorry. Year of the mask. Yes?
So on a test, if this was to come up, you want both?
You know,
answers or just
if I don't say anything, then you can put whatever you want. But there's some I'm going to make you put the us name just to make sure you know what you're talking about, okay? But if I don't say, I'll take either one. All right, let's do a little practice. That's where I give you the formula. You come up with a name. Now, oh, that's what this is too. Let's go all the way over here to this page. Let's pick number 1, number 2, and number 10. Yeah, that'd be good. 1, 2, and 10. Let's practice. 1, 2, and 10. 1, 2, and 10. I know you've been gone for a while. I didn't see you on Friday, Saturday. 1, 2, and 10. I don't know about you, but if I was in a chemistry class in high school and I was getting better and better at this, I'd start feeling a little more powerful. Like I really am learning this stuff pretty well. You did this in 10th grade, just a certain amount of it you didn't retain, right? So you're trying to master it this year. Okay, who wants to volunteer for the first one? Oh, you're still working? Okay, go ahead and work. All right, let's try it. On number 1, who wants to volunteer for that one? Yes.
So ammonium would be NH4, and then you could put that in the little parentheses, and it would have a little 3 subscript, and then you have PO4.
Okay, so phosphate was -3, ammonium is +1. That's not going to work unless you give me 3 of the +1s. What's 3 times +1? That works. Now I add it to 0. Very good. Number 2. Somebody hadn't answered one yet today. Well, everybody's answered something. Kelly, you gonna do it?
Oh, is it FeO?
Fe what?
Oh,
Okay, iron 2 means that iron is +2 and oxygen, it's not a peroxide, is -2. FeO, very good. And number 10. Yes.
PB, parentheses, CrO4, and then a subscript in front of the parentheses.
Say it again, CrO2, parentheses around this?
CrO4, yeah,
How many?
2.
Okay. So lead 4 means I'm +4, but chromate's -2. So how do I get that to add to 0? I need 2 of the -2s. That gives you -4. Everybody okay? Again, you got practice. We just practice. Let's go on. All right, let's do this one. Here's what I'd like you to do. Go through, if I were taking a test on this, I'd probably do the acids first because you'll forget to name it like an acid. So what I like you, then I would, if I had the acids, I'd do the ones that had no oxygen first. Let's do that. Do the acids with no oxygen first. Take about 3 of them. Find the acids with no oxygens and do those first. That'll reinforce that. So we're doing the acids with no oxygen first. Then you go back and do the the ones that have oxygen, but the polyatomic ends in 8. You want to do those. Then you go back and do the polyatomics that end in ite. They were acids. Are you feeling a little bit better at this? Feeling pretty good? Could you teach somebody this? I think Gabby feeling pretty good about that? All right, let's take a look and let's start at the back. Jonah, you start us off. What's number 1, real quickly? Yes. All right, now we'll jump way over here. Jeb. Yes. Tim. 3.
hydrosulfuric acid.
Yeah, don't do that. When's the only time you use hydro? When there's no oxygen. What's this one?
Sulfuric acid.
Yes. Next one. Reynolds. Yes. I'll go back up now.
Acetic acid.
Acetic acid.
Hydrochloric.
Yes.
Nitrous acid.
What is it?
Nitrous.
Yes.
acid.
Phosphoric acid.
Yes.
And then you hydrosulfuric.
Oh, hydrosulfuric. Next one. So it's got carbonate. So it's just carbonic acid. Okay. Okay, now let's switch around a little bit. What if I give you the name? What I would do is I do attack all the hydros first, because remember, they don't have any oxygen in them, do they? So go after all the ones that say hydro. Oh, hydro? No oxygen? I bet you have H because you're an acid. And what's the other element? Chlorine? Okay. -1, +1. Do another hydro. Hydrofluoric. No oxygen, so let's just be that. And fluorine's -1, +1. Any more? One more hydro. Look at hydro. You're -2 in a compound. You're +1. Uh-oh. Uh-oh. What am I going to do about that one? I need 2 of those, don't I? So I got that done, don't I? Now do all the ones that end in, they don't have hydro, but they end in ic. And say, I know what polyatomic's in you, sulfuric. You have the famous sulfate. And you have the famous nitrate. And you have the famous acetate. Oh, I better put some hydrogens in here. How many hydrogens do I need to make a compound out of sulfate? Because each hydrogen is +1, isn't it? 2 times +1, +2, -2, +2, -2. How many do I need for nitrate? 1, +1, -1. How many do you need for acetate? Okay. Phosphorus, trying to trick me there. Not phosphate, but phosphite. What do you think? All right, so carbonic, this would be carbonate. That's -2. Did I tell you had to know your polyatomic ions?
Wouldn't phosphite still be -3?
Where you at?
Or for phosphorus acid?
This is phosphorus.
Yeah, that's still a charge of -3, right?
Oh, man. I'm off today. I'm sorry. All right, you're right. My fault. Carbonic has carbonate in it, so I need 2 of those. Nitrous. Not NO3, but NO2. There we go. Phosphoric. PO4 -3. And I need 3 hydrogens. There you go. All right, and then let's do the last ones. The last thing we're going to do is everybody's favorite, but you're not going to miss these. But do not look at subscripts for anything except non-metal, binary. These are binary, aren't they? They're binary molecular. Is that right? All right. Let's see. Let's start. Caroline, you start, and let's go down. Let's go across again. First one, go.
Carbon dioxide.
Go.
Carbon monoxide.
Go.
Sulfur dioxide.
Yes. Go.
Sulfur trioxide.
Yes. Caleb, return to the corner.
Wait, some of these are
5.
5.
Dinitrogen what?
Oxide.
Now remember, you don't use mono for the first element, but you do on the second. Dinitrogen what?
Monoxide.
Monoxide. Dinitrogen monoxide. Next.
Nitrogen monoxide.
Yes. Next.
Dinitrogen trioxide.
Yes.
Nitrogen dioxide.
Yes.
We're on
9.
Dinitrogen tetroxide.
Yes. Hard one. Next one.
Dinitrogen pentoxide.
Pentoxide. Yes.
Phosphorus trichloride.
Yes. Jim.
Phosphorus pentachloride.
Yes.
Nitrogen chloride.
No, it's ammonia. Now, you have to remember that even though, just playing with you, it is ammonia, they'll never call it nitrogen trihydride, but that's what it should be called. And wait, I know, it should be called that. What should we call that? Dihydrogen monoxide. But anyway, ammonia is such a common, it's been around so long. Not ammonium, but ammonia. But you're right, nitrogen thanks for being a good sport. I went through your pencil once. Next one.
Sulfur hexachloride.
Yeah. Jonah. Pentoxide. Okay. Anyway, I knew that was not going to be a big deal. You see that? But don't look at subscripts for other compounds like that. Now, tonight, what I would do is, if you want to practice here, or you could just work on your homework. But tomorrow, I'm going to get you in little teams, and we're just going to practice, okay? We're going to practice writing. We're going to practice polyatomic ions. And you should be in pretty good shape by the end of tomorrow. And that still leaves us a day. If you want to work on homework and practice some more, we can do that. I might want to wrap up. We might want to wrap up some of the scientists again. We could finish up some of the scientists on Wednesday too.
It's 15.
All right, thank you very much.